Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from unit commitment. The name of a topic is methods of unit commitment, in which first method is a priority list method. Let's have a discussion about the priority list method. This is the simplest unit commitment solution method which consists of creating a priority list of a units. Now in this method, we are going to calculate full load average production cost for every unit. Then we are going to arrange the units in the fashion of ascending cost. Now here, let's say the priority method is a very fast and efficient method. The full load average production cost is nothing but the heat rate multiplied by the fuel cost, that is Fi, or it is Pi also. Mathematically, it is represented as full load average production cost will be equal to net heat rate at full load into fuel cost. So therefore, I can write a formula of FLAPC which will be equal to cost, which is nothing but let's say Ki, into net heat rate at full load. So how it is calculated? HI PGI divided by PGI, where this PGI will be equal to what? It will be equal to PG maximum. For example, let's say suppose I have an equation. Let me write this equation first. If the heat rate of the unit is given as, let's say H1 will be equal to 510 plus 7.2 into Pg1 plus 0.00142 into Pg1 square, and the cost of the generation, let's say suppose if it is given as K will be equal to 1.1. So how to determine this FLAPC? And let's say suppose the minimum and the maximum generation of that Pg1 has also been given, which will be equal to what? Which will be, let's say, in between 150 to 600. So now I'll write it here how to find it out, FLAPC. So how to find it out here? First one is nothing but Ki, which is nothing but cost, so which will be 1.1 into HI PGI. Now what is your equation here? You take this I equal to 1, so it will be H1 Pg1 and Pg1 will be equal to Pg max. So how to write this expression here? Here simply I can write the expression as into bracket 510 plus 7.2 into this will be what? This will be your maximum is 600. So I will write it here 600 plus 0.00142. So I will write it here 0.00142 into 600 square. Okay, I'll write it at this point, divided by this PGI, and PGI will be equal to PG max, which will be equal to 600 for this case. So if you solve this, 1.1 into 510 plus 7.2 into 600 plus 0.00142, 600 into 600 divided by 600, if you solve, you'll get answer as 9.7922. So this will be what? This will be a full load average production cost of this particular unit. Now if we have 3 units, let's say, so depending upon this FLAPC, we have to arrange the cost in the ascending order in such a way that the unit whose cost is less should be used first, then the unit whose cost is more than the first one should be turned on. Likewise, here we are going to give a priority to the unit. That's why this method is called as a priority list method. Now let's see the steps which will be involved in this particular priority list method. First, determine the full load average production cost for each unit. Then form a priority order which depends upon average production cost, and it will be in a descending order. Now commit the number of units corresponding to the priority order. If we have 3 units and the priority order has been decided, then whose production cost is less, first turn it on, then next turn it on, and then third one. Then compute from economic dispatch problem for feasible combinations only. Means if let's say suppose if I have a demand of 500 megawatt, okay, and I have three units, unit 1, unit 2 and unit 3. So suppose after priority list method, suppose the order of unit is like this 3, 1, 2, which depends upon your full load average production cost. Now in order to meet this 500 megawatt, let's decide whether to turn on only third unit or 3 plus 1, that is 2 units, or 3 plus 1 plus 2. So we have to, what we have to do? Here we have to calculate the feasible combinations. Now each hour load is changing basically. Assume the load is dropping or decreasing, whether falling the next unit will supply a generation and a spinning reserve. So let's say if there is a change in the load, then we can decide which unit should be turned on. If not, continue as it is, and if there is a change in the load or drop in the load, then determine the number of hours H before the unit will be required again. Check whether that H is less than minimum shutdown time. And if there is a drop in the load, if it is yes, then go to the last step. If not, go to the next step. Next is calculate the two cost here. So sum of hourly production cost for the next H hours with unit up, and recompute the same for the unit down, the startup cost for either cooling or banking. If the second case is less expensive, then the unit should be turned on. So while solving the numerical, we have to focus on these first two steps only. First, we have to find it out full load average production cost, and depending upon that full load average production cost, we have to make ascending order of the units. And for a particular demand, whatever we have given in the system, for that particular demand, we need to decide whether to turn on all the units or combination of two or only one unit. So this is what is the priority list method. In the next video, we are going to discuss about how to solve a problem of unit commitment with the help of priority list method. In that, we are going to discuss some numerical. Thank you for watching this video.